Over to you, Dotan.
Thank you very much, and very glad to be here at the DevOps conference. And let's start with a question, as we just said. And the question is, how many tools does a company use on average to collect telemetry data from its systems? And you have on the tab there on the poll, so you can answer how many you think, how many tools for collecting telemetry, think logs, metrics, traces, front end, back end, infrastructure, cloud services, everything. How many do you think? Let's have a look and see what's on the poll side. Give a few seconds for people to submit response. Okay, I see we have some votes for the majority for the 2 to 4, I see, 52%, 5 to 10, 30% say, 13% think that 11 or more. So that's interesting, and actually you're not far off from the truth. And the reality is that organizations use between 5 to 10 different tools to collect telemetry data from their systems. 5 to 10 tools. You can reduce it to one unified standard platform. Here's the story of OpenTelemetry. A word about myself. My name is Dotan Horovits. I'm a developer advocate at logs.io. At logs.io, we provide cloud-native observability platform that's based on open source tools such as Elasticsearch and OpenSearch, Grafana, Jaeger, Prometheus, and also OpenTelemetry, amongst others. And by the way, we are recruiting, so if you are interested, do check us out. I'm an advocate of open source and communities. I run the local CNCF chapter in Tel Aviv. We run monthly meetups. If you happen to be around, you're more than welcome. I also have a podcast called Open Observability Talks that talks about open source observability and DevOps. So check it out on your favorite apps. And in general, you can find me everywhere at Horovits. So if you are tweeting something interesting from this talk, do tag me. And let's go over to observability. As we all know, observability is essentially the ability to understand the state of our system based on the telemetry that it emits. And the vision talks about unified observability across the different signal types, typically, as you can see on the screen, metrics, logs, and traces, and also across different sources. Think about front-end code, back-end code, open source tools, your Kafka, Redis, MySQL, whatever, cloud services. Just fuse all of these together to gain unified observability. That's the vision. The reality, however, is much more fragmented. And the reason is exactly what we saw there on the poll, on the question, that we use many tools for our observability. And each tool and each vendor has its own proprietary API and SDKs for instrumenting our application. Just think about your Datadog agent and Splunk agent and New Relic and Jaeger and whatever for client libraries. And then also proprietary agents and daemons and collectors to collect and run all the aggregations and sampling and processing. And then proprietary protocol and data model for transmitting the telemetry data to analytics backend. And of that, it's not only an operational headache to run these so many tools and the vendor lock-in issue. It also creates tight coupling between the telemetry collection and the telemetry storage and the analytics backend. And that makes it very, very difficult to correlate data between these sources and gain that observability across the different data silos. That's what OpenTelemetry comes to solve. OpenTelemetry, or OTel as it's nicknamed, is an observability framework for generating and capturing telemetry data from cloud-native software. And it's across all the observability pillars, namely traces, metrics, and logs. One framework to rule them all, if you like. It's an incubating project under the CNCF. In fact, it's a merge of Open Tracing and Open Census, if you're familiar with these preceding projects. And I'm glad to say that OpenTelemetry has been adopted by all the major vendors out there, all the monitoring tools, all the cloud providers. Everyone is aligning behind OpenTelemetry, which is what you need to make sure that you get a de facto standard and the consolidation in our industry. And the second thing that is important is obviously having an active project. So we are in a DevOps conference. You can't go by without a dashboard. So here's the CNCF DevStats dashboard. And as you can see, OpenTelemetry is currently the second most active project on the CNCF, second after Kubernetes itself, which is extremely impressive. So I hope that I was able to convince you that OpenTelemetry is interesting and that you'd like to hear some more. And with that, I'd like to dive deeper into what exactly OpenTelemetry provides us. OpenTelemetry provides a unified set of APIs, SDKs, and tools for generating telemetry data, logs, metrics, traces from our applications. This is the bluish part on the left-hand side of the diagram on your screen. And then a standard way for collecting that telemetry data, both from our application and from other resources and infrastructure and others. That's the green part in this diagram. And then a standard way for transmitting and exporting the telemetry. That's the orange part. And then exporting it to whichever backend analysis tool of your choice. Prometheus, Jaeger, Zipkin, Logs.io, whatever you want. OpenTelemetry doesn't have any say in that. It doesn't really take a stand in that. So that's OpenTelemetry in a nutshell. And don't worry, I'm going to dive deeper into each and every one of these in the coming slides. But before that, I would like to say a word about something that is not a component per se, but rather governs all the components, and that's the OpenTelemetry specification, which describes the cross-language requirements and expectations of all of OpenTelemetry's implementations. So it defines the API spec, the SDK spec, the data spec, things such as semantic conventions and so on, across traces, metrics, and logs, all the three pillars of observability. And this is important because this comes to solve the exact problem that we talked about before of fragmentation, that each vendor and each programming language and each signal has its own convention. And another important point is that a unified data spec and the semantic conventions across the different signals will enable correlation between the different signals and the different sources. So that's why OpenTelemetry specification is essential, although you'll not be interacting directly with it typically. And let's move on to the first component that you're likely to meet when starting with OpenTelemetry, and that's the client libraries. OpenTelemetry provides one API and one SDK per language. That's based, of course, on the specification we saw for instrumenting your app. So you have Java SDK, a .NET SDK, a Golang SDK, a Python, and so on and so forth. It also has language-specific integrations with popular web frameworks, storage clients, RPC libraries, and so on that can automatically capture some telemetry off of these frameworks. And also auto-instrumentation agents, automatic instrumentation that allow to collect telemetry from some applications without requiring code changes. So to summarize in a nutshell, OpenTelemetry aims to provide the full range from a fully managed manual, to a fully automated instrumentation and anything in between. And that's important to know because many think only on the manual side of things. It's not only that, definitely. So that's on OpenTelemetry client libraries. The second component is OpenTelemetry collector. And the collector can collect data from different from the SDKs that we talked about before on your application code, but also from other sources. It could be, I don't know, Kafka, MySQL, Redis, AWS, Azure, Google services, whatever, and then export this telemetry to any supported backend. And it's built like a typical data processing pipeline. You have multiple receivers, you have in different protocols, you have the processing and aggregation side, and then exporters in multiple protocols. So, for example, if your application emits traces in a Jaeger format, you just plug in a Jaeger receiver. If it emits metrics in a Prometheus format, you just plug in a Prometheus receiver. If you have Docker, Kafka, MySQL, AWS X-Ray, GCP PubSub, whatever, just plug in the relevant receiver, plain and simple. Next, you have different processes to do things such as filter, modify, batch, sample, and so on. And you can also chain multiple processes together to get more elaborate processing logic. And then you can use exporters to export to whichever backend you use. So if you use AWS X-Ray, plug in the exporter, Azure Monitor, Google, Datadog, Dynatrace, Logs.io, whichever, you have a rich library of exporters that you can plug in and export it to whichever destination you want. So that's, in essence, OpenTelemetry collector. And the last component I'd like to talk about is OpenTelemetry protocol, or OTLP. And OTLP is a general purpose telemetry data delivery protocol. It could serve, as you can see here on the diagram, to transmit between the SDK, the OTel SDK, and the collector. It could be between the collector and your backend analytics tool. It could be between intermediate nodes, like two different collectors, or any other. It's really a general purpose, client-server, request-response type of protocol. OTLP is implemented over gRPC and HTTP 1.1 transports. So you have OTLP over HTTP and OTLP over gRPC. Currently, it supports binary protobuf encoding for the payload, which just goes to show how agnostic it is, because essentially you can take the .proto file and generate your own gRPC client, raw client, if you want not to use something of the project. And by the way, there's also in the works support for JSON. So you'll have JSON encoding on top of OTLP over HTTP. And of course, last but not least, the telemetry data model that's based on the specification we talked about before. An important note I would like to make is that OpenTelemetry does not mandate you to use OTLP. As we saw before on the collector, there are receivers in multiple protocols, you have exporters in multiple protocols. So still, the OpenTelemetry as a project strives to provide a holistic, unified protocol as part of the holistic framework. So, and to enable correlation of the telemetry once it's one unified protocol. And the same goes, by the way, to all of OpenTelemetry as a whole, all of the components. You can use the collector without OTel SDK. You can use SDK without the OTel collector. You can export from the SDK in multiple ways. So it's essentially a loosely coupled, yet a holistic framework for aiming to provide a standard, unified way to generate and collect telemetry data. So these are the main components of OpenTelemetry. It's enough for the basic understanding of how it works. And next, the question that I'm often being asked is, okay, so what's the status of the open source project? And most importantly, is it GA? Can I use it in production? And the answer is, any guesses, by the way? What's the answer? Yes, no, it depends. You can just chat and write it on the chat if you want, or anything like that. Okay, I get one yes. Anyone else wants to comment? Okay, I get many on the yeses. One, it depends. Okay, so oh, I see. Okay, now it's a tie. It's a tie. Very good. So the answer is Like any interesting question out there and any interesting system, it depends. And the reason it depends is that OpenTelemetry is an aggregate of multiple groups, each working on a different component of this huge endeavor. So you have a group working on the tracing specification, another on the metric specification, another on the logging specification, and then you have the Java group and the .NET group and the Go group and so on. And each group has its own release cadence, which means that different components of OpenTelemetry may be in different stages of the maturity lifecycle. And the maturity lifecycle is what you see at the bottom of the screen. That's a standard CNCF OpenTelemetry draft to experimental to stable to deprecated. Put in maybe common terms, stable would be the equivalent of a GA, generally available, which is what you'd be seeking to run it in production environments, stable with long-term support and backwards compatibility guarantees and so on. And experimental is sort of the beta stage that should enable testing the technology for evaluations and POCs towards integration. So that's in general the status. Another to understand the structure, but still the question remains, so what's the state of OpenTelemetry? And I'd like to break it down by signal types. And the first and the most mature signal is traces. And I'm glad to say that OpenTelemetry is stable for traces. That means GA, the API is GA, stable, SDK, the protocol is stable, the data model specification. You have many client libraries that are version 1.0 or above. 1.0 is, by the way, once the tracing implementation is complete. So Java is there, and Go, .NET, Python, C++, JavaScript, Ruby, Erlang, working on PHP and Rust and Swift. And I might have missed, because this keeps progressing so rapidly and so many groups that I might probably be missing several. And as we said, the most important thing, that stable means long-term support, backwards compatibility, dependency isolation, the things that you would be looking for to run in production. And I can tell you, we, for example, at Logs.io, we use that in production systems very happily. So I can testify firsthand that it works.
Hi, we are Eficode, and we organize the DevOps conference. Delivering the benefits of DevOps through cloud gives the scalability, availability, and cost effectiveness we all want. We would love to speak to you to learn how we could help you to do DevOps better in the cloud. You can find us at eficode.com. The links are in the description, and have a great time with the DevOps conference talks.
Next up is metrics, that is expecting stability within the coming months. The protocol and is stable with the data model already part of OTLP. API is stable, the SDK is in feature freeze and soon to be stable. The metric API and SDK specifications are already prototyped in several languages, Java, .NET, Python. On the collector side, we have experimental support for metric pipelines. And the support for Prometheus under development, together with collaboration with the Prometheus community, part of the advantages of having both of them under the CNCF roof. And by the way, although it's not yet stable, I can tell you that formally, I can tell you that we at Logs.io, for example, already use the metrics piece of the OTel also to import metrics from different systems, from Kubernetes, Docker metrics, and so on. So definitely well advanced. And the least advanced is logs. That's still experimental, the community is aiming to get it out by the end of the year, 2022. The protocol is still experimental. The data model is released as part of the OTLP as experimental. The collector is experimental, but it actually got quite a bit of advancement thanks to the contribution of Stanza project. So lots of log processing in many data formats been added. On the API and SDK sides, they're both on draft stage. And I would say that our focus in the community, since logging is the most, long-standing part of the telemetry, and every system has logs already in place. So the logic has it that first focus should be to integrate with existing logging systems, to fetch the logs, to transmit them over OTLP, and so on. There's a lot of work also on log appenders. Also, some of my teams at Logs.io working hard on that to get, if you have already a log appender in place, so we can piggyback on that and, for example, add tracing data to existing logs like trace ID, span ID, and other metadata on top of that. Another very interesting thing that was just released last week, I think, was starting support for work on supporting ECS, Elastic Common Schema. So a lot of work also on the log front. So that's in a nutshell the state of the signals. And the last part that I would like to give this talk is how to get started with OpenTelemetry. It could be confusing with everything that I described, so I would like to give my bit of advice about that. And it starts by knowing your stack. These are the main questions that you need to ask yourself. First, which programming language do you use in your system? Front and back end, if you're a polyglot organization in particular, and also maybe which frameworks you use with that. For example, we use on the front end the Node.js with Happy and Express. We use the Java backend with Spring or things like that. So understand this, because this will determine the client libraries and maybe instrumentation agents that you would want to use out of OpenTelemetry. Next, understand which signals you're interested in collecting, logs, metrics, traces, and also, very importantly, in which protocols. And that's especially important if you're a brownfield project, already having infrastructure pieces or existing code that already emits logs, metrics, or traces in specific format that you need to conform to, that you don't want to change. So you have an old piece working with Zipkin traces, and you want to collect that. So that will determine your receivers. And then which analytic tool you're going to use to analyze in the backend and to store, that will determine the exporters. And once you've mapped these elements that you need out of OpenTelemetry, then you can go ahead and check the status for each and follow the respective guides. And there's a very useful page that we've added to OpenTelemetry, OpenTelemetry.io /status, that provides a high-level status of the project. I would advise starting there. It's a good place. And another recommendation would be to check out the guide to OpenTelemetry that I wrote. You can screenshot here and see the bit.ly, or you can just Google OpenTelemetry guide or OpenTelemetry tutorial, something like that. It's pretty popular, so it probably come up in the top 3 or something like that. And it outlines very detailed each and every one of the components that I mentioned, the status of things. It has sub-guides to the different languages. So if you want a quick hello world setup in Java, you have the Java sub-guide, the .NET sub-guide, Node.js, Python, Ruby, very quick to set up an initial setup. And of course, useful links to further drill down per your stack. So feel free to check it out. And if you have any feedback or comments, do share them. I'd be happy to make it even better. And the last point I would like to make, I'd like to leave some time for questions at the end, is beyond the feedback on my guide, is to get involved. OpenTelemetry, after all, is an open source project, and it's you can check out the GitHub for issues and comment on the issues, open issues, PRs, contribute code, whatever you can do to make sure that OpenTelemetry is indeed a useful framework for collecting telemetry, and that can become really a de facto standard and unifying and converging in the industry from the pains that we talked about. So if you have any feedback on this talk, on the guide, on OpenTelemetry or anything else, feel free to reach out to me at Horovits on Twitter, on LinkedIn, on Medium, on wherever, GitHub, everywhere there. And I'm Dotan Horovits. Thank you for listening, and I think we have a bit of time for questions. So let's see if there's anything interesting to discuss.
Cool. Thank you, Dotan. Yes, we have 9 more minutes for questions before we go over to the next talk. I see there are some questions posted in the Q&A, so we want to go through those. We will go by upvotes, so we will just start there. Can you tell us something about the security consideration taken into account when designing the OTel components, spec, and protocol?
So security is definitely a central concern in any of the groups. When in the specification side of things, in the architecture of the collector. So it's a very broad question that really depends on the specific elements within. But there are lots of discussions regarding security elements. It doesn't, by definition, for example, if you're looking to clear out PII or things like that out of data when you collect it, or things like that, for example, that we do, it's not something that is built into the framework. The framework is just the plumbing. You will need to implement your own logic if you have custom, PII sensitivity or other things that you need to filter out. But in terms of the protocols supported, in terms of the design, it's definitely top of mind.
Cool, thanks. And a question from Robin. How well does hyperscalers support OpenTelemetry in their SaaS solutions?
By hyperscalers, just to make sure that I understand, are these companies that are like web scale companies? Is that the question? I can tell you maybe while being asked, in terms of the adoption, I can tell you, for example, we, as I said at Logs.io, we support that, and we use that for our own observability. I can tell you that many others adopted that, including tier 1 companies such as AWS and others. So it's definitely not something just for the niche and small scale. It's definitely something that is adopted across the board. I don't know if that addresses the hyperscale part, but
yeah, he clarified hyperscalers in this case are like Azure, AWS, like the big cloud providers.
So okay, so it's widely adopted. I can even say that they provide that as supported. For example, AWS has what they call open distro for OpenTelemetry. That it's a downstream distribution that is aligned, of course, with the open source, just with their own set of tests and additional plugins and the ecosystem for their own ecosystem. But that's the way forward that they anticipate sending telemetry into AWS, collecting from AWS. So, for example, if you look at receivers, you have receivers collecting from AWS X-Ray and other services. You can also find exporters exporting that telemetry to AWS services of sorts. So it's really integrated, and it's definitely on their roadmap as well in terms of their own services.
Cool. Okay. Yeah, I was wondering, like, if I were to host this or myself, where would you recommend hosting it? Especially if let's say I'm ingesting also trace for my Kubernetes application, would it then make sense to host it inside the same cluster, or are the best practices that you host it somewhere else?
So by hosting, I assume that you're talking about OpenTelemetry collector. That's yes. The piece. So this piece usually is in the same cluster. It's a logic very similar to many others, like StatsD or CollectD. I don't know which one you've been working with, but it's very similar in the terms of the network topology, because we would like it to be very easily accessible to the sources. The SDKs, of course, are on the same container, because it's libraries that are co-located. So this is the typical setup again, but it really depends. Some have constraints, DMZs that you need to transfer above. This is why I mentioned intermediate nodes that you might want to relay through. So that there are other architectural considerations there, but in general, you need to have it accessed. I should maybe also mention that there is flexibility in the architecture also in terms of the pull and push mode. So some would prefer, for example, collecting metrics very similarly to Prometheus in a pull mode, and then you'd need the access to access all the remote targets and fetch them. Some would prefer to do it in a push mode. So again, other considerations that might impact the topology.
Thanks. Another question came in. How can we make the instrumentation process for applications running on different languages to adapt to changes in design or process of collecting metrics/traces?
That was a long one. I'm just opening the question to read it myself, make sure that I understand. How can we make the instrumentation process for applications running on different languages to adapt to changes in design or process of collecting metrics and traces? So again, different languages means that you use different instrumentation for each. So you have, as I gave the example, Node.js on the web app side, let's say, and the Java for the backend. So you would need different SDK, obviously, for each one of these, because these are different languages. However, since they're based on the same OTel specification, it means that the output that the SDKs emit is already standardized and is aligned. So when it uses the same semantic conventions, the same data schema. So afterwards, from the moment it exits, it is emitted from the SDK, it's already standardized, and in the collector side, you can also already start treating it uniformly in the processing, in the aggregation, in the sampling, filtering, dropping, batching, whatever. So this is, in a way to overcome this polyglot situation of many languages across the environment, and also changes. You mentioned the changes in design or process. So if some pieces were off Kubernetes and you move to Kubernetes, for example, the change should be very limited to the instrumentation side rather than having it across the board in the old way of working when it's tight coupled between the instrumentation and the backend.
Cool. I guess the last question, is OpenTelemetry Java, the open tracing shim, stable and ready for production? Asks Goran.
So the Java SDK is already definitely GA. I don't remember. It's past, as I said, GA is like version 1.0 is when the tracing implementation is complete. So it's post 1.0. So it's already good for tracing. As I said, the question might be confusing because it depends if it's for tracing or for metrics or for logs. So for tracing, it's GA, it's post version 1.0. For metrics, it's still one step earlier. So this is why we need to check the status according, as I said, know your stack, and depending on your own needs. I'm looking to see if in the question you mentioned exactly what you're going to look. You're looking to open tracing shim. So you're looking for the equivalent for the shim. That's a good point. For those, I didn't spend so much time on this, but as I said before, OpenTelemetry is a merge of OpenTracing and OpenCensus. Now, both of them, OpenTracing and OpenCensus, that are under the CNCF, has been deprecated. So if you are using OpenTracing or OpenCensus, please start the migration. However, to ease the migration, the shim has been supported to enable this. And as far as I know, it's good to go. So if this is what you're looking for, and now that I see the question in front of me, then definitely it's a good way. I would recommend not just using the shim, because then you're still with the old APIs and it does on the backend transitions. I would invest more time to move to the native OTel APIs. And also down the road, you'll have more capabilities that are not supported by the standard Open Tracing API. But if you need a quick way to do the first phase, to just deprecate Open Tracing library and dependencies from your Maven or whatever, then definitely go about with the shim. Just again, take the extra step. Don't neglect the technical debt of moving to the native APIs, because otherwise it will start backfiring later down the road. Hope that it helps.
Thank you, Dotan. It was a pleasure.